Hi, I'm Lyn Syuen, and now I will be explaining about exercise 7.6, question 1. Here it says find the volume and surface area of the solid with the net shown in the diagram. So first we will be finding the volume. As we can see here, this is the net of a triangular prism. To find the volume of a triangular prism, we take 1/2 times the base times the height and times the length of the triangular prism. Okay, we can see here that the base is 4 cm, the height is 3 cm, and then the length is 11 cm. So the calculation will be 1/2 times 4 cm times 3 cm times 11 cm, which equals to 1/2 times 132 cm cubed. So we will divide it by 2, and at the end we will get 66 cm cubed. So the volume of this triangular prism is 66 cm cubed. Now moving on to its surface area. For the surface area, let's look at the triangle first. So there are two triangles here, as you can see, and the measurements are the same. So to find the area of a triangle, we take 1/2 times the base of it and times the height. So the base here is 4 cm and the height here is 3 cm. So we take 1/2 times 4 times 3 cm, which equals to 1/2 times 12 cm. So we take 12 cm and divide it by 2, so we will get 6 cm. Hence, we know that the area of one triangle here is 6 cm. And since there are two triangles which have the same measurements here, both of them are all 6 cm. Now let's look at this rectangle here. To find the area of a rectangle, we take the length times the width. So we will get 11 cm times 3 cm, which we will get 33 cm squared. So we can see that this blue rectangle here, the area of it is 33 cm squared. Okay, now let's move on to this rectangle. Same as it is also a rectangle, we take the length times width. Hence we will get 11 cm times 4 cm, and the answer we will get is 44 cm squared. So we can see that this red rectangle here is 44 cm squared. Now we'll move on to this rectangle here, this green rectangle. Same, we also use the length times the width, which we will get 11 cm times 5 cm, and we will get 55 cm squared. Okay, now to find the total surface area of this solid, we have counted the surface area for all of the shapes here, so now we need to do is just add them all together. Since we have two triangles here and one triangle's area is 6 cm squared, we will add 6 cm squared plus 6 cm squared plus 44 cm squared, which is the red rectangle here, plus 33 cm squared, which is the blue rectangle here, and finally we add 55 cm squared, which is the green rectangle here. At the end, we will get 144 cm squared. Now moving on to question 2, here it says find the volume and the surface area of the cuboids with the following dimensions. Now let's look at question A first. In question A, it says the length of the cuboid is 5 cm, the breadth 8 cm, and the height is 18 cm. Now let's look at how to do it. Firstly, let's count its volume. So the volume of a cuboid, we all know that it's the length times the breadth times the height. The length here is 5 cm, the breadth 8 cm, and the height is 18 cm. Hence, we just need to times them together, so 5 cm times 8 cm times 18 cm. And at the end, we will get 720 cm cubed, which is the volume of cuboid A. Now let's look at the surface area of cuboid A. In the cuboid, there will be 3 faces with different measurements, and each different face will have 2 of them. So here we take 2 of 5 cm times 8 cm plus 2 of 8 cm times 18 cm plus 2 of 5 cm times 18 cm. So as you can see, measurements they multiply together are different. Okay, hence we will get 2 of 40 cm square plus 2 of 144 cm square plus 2 of 90 cm square, which equals to 80 cm square plus 288 cm square plus 180 cm square, which we add them all together, we will get 548 cm square. Hence, 548 cm square is the surface area of cuboid A. Let's look at question B. In question B, it says that the cuboid has a length of 1.2 millimeters, a breadth of 2.4 millimeters, a height of 4.8 millimeters. Now let's count its volume first. Volume, as we all know, it is the length times the breadth times the height. So it is 1.2 mm times 2.4 mm times 4.8 mm, which we will get 13.824 mm cubed. And after we change it to only one decimal place, we will get 13.8 millimeters cubed, which is the volume of cuboid B. Now let's look at its surface area. For its surface area, we will take 2 of 1.2 mm times 2.4 mm plus 2 of 2.4 mm times 4.8 mm plus 2 of 1.2 mm times 4.8 mm. And as you can see here, all of the calculations, the measurements that they multiply together are different from each other. So here we will get 2 of 2.8 mm square plus 2 of 11.52 mm square plus 2 of 5.76 mm square, which equals to 5.76 mm square plus 23.04 mm square plus 11.52 mm square. And we add them all together, we will get 40.32 mm square. And after we convert it into only one decimal place, our final answer will be 40.3 mm square. Hence, 40.3 mm square will be the surface area of our cuboid B. Let's move on to question 3. Question 3 here, it says that the diagram shows a bottle crate. We need to find the volume of the crate. We can see that the shape here is a cuboid. And to find the volume of a cuboid, we take the length times the width times the height. And the length here is 90 cm, the width is 60 cm, and the height is 80 cm. So we multiply them all together, we will get 432,000 cm cubed. Okay, so now let's move on to question 4. Question 4 here, it says that the diagram shows a pencil case in the shape of a triangular prism. We need to calculate the volume and the surface area of the pencil case. Now let's look at the volume first. To find the volume of a triangular prism, we take 1/2 times base times height times length, which here we can see that the base is 6 cm, the height is 8 cm, and the length is 32 cm. So our calculation will be 1/2 times 6 cm times 8 cm times 32 cm, which equals to 1/2 times 1536 cm cubed. And our final answer will be 768 cm cubed. So 768 cm cubed will be the volume of this triangular prism. Okay, now let's look at the surface area. Okay, for the surface area, we can see here in this triangular prism there is a total of 5 faces. Now let's count the area of the triangle here first. There are 2 triangle faces here. So to find the area of a triangle, we take 1/2 times the base times the height, which here it is 1/2 times 8 cm times 6 cm. And since there are two triangles, we will add two of them together. And this face here, we can see that it's a rectangle. So to find the area of this rectangle, we take 10 cm times 32 cm. And now we add the side here, which can't be seen in this diagram, but we do know that to find it, we will need to times 8 cm times 32 cm, since the side here is also a rectangle. And now we need to calculate the area of the bottom face. Here we can see that the length of it is 6 cm, so we take 6 cm times 32 cm. So as you can see here, we have a total of 5 faces together. 1, 2, 3, 4, 5. And now adding them together, the two triangles add up to be 48 cm square plus the other faces, which is 320 cm square, 256 cm square plus 192 cm square. After adding them all together, we will get 816 cm square, which is our surface area of this triangular prism. Now let's move on to question 5. Here it says that the diagram shows a cylindrical drain, and we need to calculate the volume of the drain. So to find the volume of a cylinder, we take pi times the radius square times the height. We can write pi as 3.142, and the radius here is 0.6 meters, because as we can see here that the diameter is 1.2 meters. And since the radius is equal to the half of a diameter, so to find the radius, we take the diameter and divide it by 2. 1.2 meters, we divide it by 2, we will get 0.6 meters. So 0.6 meters is the radius here. The formula, it says that radius needs to be squared, so 0.6 meters times 0.6 meters times the height, which is 3 meters, as we can see here. After multiplying them all together, we will get 3.39336 meters cubed. And after changing it to 2 decimal points, we will get 3.39 meters cubed, which is the volume of this drain here. Now moving on to question 6. It says that the diagram shows a tube containing chocolate sweets. We need to calculate the total surface area of the tube, including the 2 circles here. To find the total surface area of this tube, we take 2 times pi times radius square plus 2 times pi times radius times height. The 2 pi radius square here is referring to the formula to find the area of the 2 circles, and this is the calculation to find the side in the middle here. Now pi, we can write it as 3.142. The radius here is 1.1 since the diameter is 2.2. So to find the radius, we take 2.2 divided by 2, which we will get 1.1 cm. Hence, the 2 pi radius square here will be equal to 2 of 3.142 times 1.1 cm times 1.1 cm. And we need to plus it by 2 of 3.142 times 1.1 cm times 10 cm. As you can see here, the radius is 1.1 and the height here, we can see that it's 10 cm. So the calculation here will equal to 2 of 3.80182 cm square plus 2 of 34.562 cm square, which also equals to 7.6036 cm square plus 69.124 cm square. Adding them up together, we will get 76.72764 cm square. And after converting it to 1 decimal place, we will get 76.7 cm square, which is the total surface area of this tube. Okay, moving on to question 7. Here it says that the diagram shows the solid glass case for a clock. The case is a cuboid with a cylinder removed to fit the clock mechanism. We need to calculate the volume of glass required to make the clock case. So basically, we need to calculate the volume of this cuboid here. We also need to calculate the volume of this cylinder, which needs to be removed. And we need to take the volume of the cuboid and we minus it by the volume of the cylinder since it will be removed to find the volume of glass required to make the clock case. Okay, so now let's calculate the volume of the cube first. To find the volume of a cuboid, we will need to multiply its length times its width times its height, which here our calculation will be 8 cm times 4 cm times 10 cm, which the answer will equal to 320 cm cube. So 320 cm cube will be the volume of the cuboid without the cylinder removed first. Now we find the volume of the cylinder. The cylinder here, to find the volume of a cylinder, we need to take pi times radius square times height. Pi we'll write it as 3.142. The radius here we know that it's 2.5 cm. Since its diameter is 5 cm, so to find the measurement of the radius, we take 5 cm divided by 2 and we will get 2.5 cm. So now we know that our radius is 2.5 cm and the height here is 4 cm because, as you can see here, the width of the cuboid is 4 cm, which is also the height of the cylinder. Now, our calculation will be 3.142 times 2.5 cm times 2.5 cm times 4 cm, which will get 78.55 cm cube, which is our volume of the cylinder. Now, since it says that the cylinder here is removed, we take the volume of the cuboid and minus the volume of the cylinder. Hence, it will be 320 cm cube minus 78.55 cm cube, which we will get 241.45 cm cube. And after converting it to just 3 significant figures, our answer will be 241 cm cube. Now let's move on to question 8. Here it says that a storage company has a rectangular storage area 20 meters long, 8 meters wide and 2.8 meters high. For question A here it says to find the volume of the storage area. Now to find the volume of the storage area, we just need to times the length times the width times the height, which is 20 meters times 8 meters times 2.8 meters, which our final answer will be 448 meters cube. So this will be our volume of the storage area. Okay, moving on to question B. It asks how many cardboard boxes of dimensions 1 meter times 0.5 meters times 2.5 meters can fit into the storage area. So to find the volume of one cardboard box, we take 1 meter times 0.5 meters times 2.5 meters, which we will get 1.25 meters cube. So now we know that one cardboard box volume is 1.25 meters cube. And just now we already calculated that the volume of the storage area is 448 meters cube. So to find how many cardboard boxes that we can fit into the storage area, we just need to take 448 meters cube divided by 1.25 meters cube, which our answer will be 358.4. So we know that we can fit a total of 358 boxes into the storage area. Okay, moving on to question C. The question is, what is the surface area of each cardboard box? Here it has already given the dimensions of the cardboard box, so we just need to add and multiply them together. Firstly, we take 2 of 1 meters times 0.5 meters, add it to 2 of 0.5 meters times 2.5 meters, and add it to 2 of 1 meters times 2.5 meters. As you can see here, 3 different measurements are multiplied together. Now, this calculation will equal to 2 times 0.5 meters square plus 2 of 1.25 meters square plus 2 of 2.5 meters square, which equals to 1 meter square plus 2.5 meters square plus 5 meters square. And our final answer will be 8.5 meters square. Thus, 8.5 meters square will be the surface area of each cardboard box. Now, question 9. Here the question says, Buyo is moving to Brazil for his new job. He has hired a shipping container of dimensions 3 meters times 4 meters times 4 meters to move his belongings. Now here there are questions A and B. Let's look at question A first. Question A says to calculate the volume of the container. Now to find the volume, we will just need to multiply the dimensions here given together, which is 3 meters times 4 meters times 4 meters, which we will get the answer for the 8 meters cube. Now moving on to question B. Question B says that he is provided with crates to fit the dimensions of the container. He needs to move 8 of these crates, each with a volume of 5 meters cube. Will they fit into one container? Now let's look at the calculations. Here it says that the volume of one crate is 5 meters square, and he needs to fit 8 of these crates into the container. Just now we have already calculated that the volume of one container is for the 8 meters cube. Now here he says that he needs to move 8 of these crates, each with a volume of 5 meters cube. So to find the volume of 8 crates, we just take 8 times 5 meters cube, which we will get for the meters cube. Now, the total volume of the container is 48 meters cube, and the total volume of 8 crates are 40 meters cube. Now 48 meters cube is larger than 40 meters cube. So the answer is yes. He will be able to fit 8 of these crates into one container.